Okay, gang, in this video, we're going to look at some limits to infinity. And type 2 just means that the functions we're dealing with are a little more complicated than your average function. And you can see in this first example here, you have kind of a hybrid between a rational function and a radical function. The numerator is radical, but overall it's a big fraction, which makes it rational. And the bottom line when you have a fraction is you really just look at the degree of the top and the bottom, meaning the highest power top and bottom. So, of course, this is not it's actually in ascending order. But up top, all we really care about is that x to the 10th. Because when you're at infinity, higher powers just dominate the lower powers. You put a ginormous number and raise it to the 10th power, that number would dwarf any power beneath it. So the 6th power doesn't even factor into it. Same thing on the bottom, 2x to the 4th kind of, it's driving the denominator there. The 4x and the 6, they're totally irrelevant. And again, it's only because you're at infinity. So really, the problem you really have here is the limit as x approaches infinity. And up top, you really just have square root of 64x to the 10th. And the bottom, you just have 2x to the 4th. And of course, we can do a little simplifying up top. The square root of 64 is 8. So we get 8x to the 5th over what? 2x to the 4th? Which really means what are we talking about here? The limit of, and again, all this math where you're just dropping out terms, it only works for limits and it only works at infinity. Otherwise, obviously I'm kind of, everything in green here, I'm just dropping out. That's nothing you've ever seen before in algebra. So this phenomenon only works at infinity. It's very important to keep that in mind. So we still have the limit of what? 4x. And guess what? 4 times an infinite number is infinite. So it's infinite, and on delta math, we would say the limit does not exist, right? We don't get any close to, we'd say it kind of grows with that. The numbers here grow without bound. They don't get any bigger. Or they don't hover down to any one particular number, so there is no limit. So let's look at another example. And I'll go a little quicker here because, the same stuff applies. All I care about is this negative 8x to the 8th. In the bottom, the highest power is 9x cubed. So if I kind of rewrite this limit, I have the limit as x gets close to infinity of the cube root of negative 8x to the 8th over 9x to the 3rd. So again, I got the limit, x gets close to infinity. Up top, the cube root of negative 8 is negative 2. And the cube root of x to the 8th, well, it's nothing good. It's just x to the 8/3. Remember, a cube root, you're really dividing the exponent by 3. On the bottom, I have 9x to the 3rd. And here, what am I doing? I'm really comparing numerator and denominator. And guess who wins here? 8/3 is slightly below 3, so the bottom has a higher power. And, you could cancel them out if you'd like. Actually, we can do that. I mean, I'm going to tell you the limit's going to be 0, but if we want to go one more, because the bottom has a higher power. That's kind of what happens at infinity. You compare the powers of top and bottom, but suppose I actually do the math here, right? If I got a 2, I got a 9, and when you divide, you actually subtract, and you get x to the minus 1/3, which means that x to the 1/3 in the denominator. And then as you start approaching infinity, right, what happens here? You got negative 2 over 9 times, the cube root of infinity, which is still infinity. And so what happens is you got 2 over an infinite number, which becomes 0. And it'll get there fairly quickly. Plug in a number like 1,000, see what happens. You'll get very, very close to 0. If you plug in 1,000,000, you'll be even closer to 0. Okay, one more example here. And again, highest power, top and bottom, x to the sixth, x to the second. Again, we're doing the limit at infinity. And I'm going to, just ignore everything except the highest power, top and bottom. This is 6x squared. And I could do a little magic up top. Not a little magic, a little mathemagic up top with cube root of negative 64. That's negative 4. The cube root of x to the sixth is x squared over 6x squared. And you can see here, of course, bottom and top tie, and the x squared is basically cancel out. So I got the limit at infinity of what? Negative 4/6, which of course is just negative 2/3. Okay. And, we did these analytically. Analytically means we just kind of tried to use some math, some algebra. You could do these graphically as well, right? Nothing's stopping you from graphing the function and looking to the far right side, like plugging in values like 1,000, 10,000, 100,000, and see what the y values get close to. That's always an option. So don't forget that. Hopefully this video helped you out. Take care.